Hello, candidates. I am part of the Irish Meat and Potato Scientists, and this week we will be hosting a potato cooking competition. Candidates will be judged on the following criteria. Most effective use of heat transfer, because we're scientists here. Speed. The faster you cook the potato, the more points you're going to get. And of course, taste, because who doesn't love the taste of a good Irish potato? Uniquely, our candidates this round are all 14-year-old girls. Go women in STEM! Let's see what our candidates are cooking up for us today.
I think the potato is going to be so much better just cooked in the oven without anything done to it. It'll be like it's sleeping in its own little oven bed. And I think the heat and mass transfer graph will look like that.
Guys, I'm sorry you had to experience that, but what I think is the best way of doing it is taking this here potato and putting it in aluminum foil. See this? This way, the heat and mass transfer, the graph will look like that.
Well, the plots won't look exactly like that. I have 3 main points to bring to your attention. First of all, as you get more towards the center of the object, the less surface area there is for the heat to transfer through. Therefore, our plots will not be linear. Secondly, we need to take into account the difference between the surface and the center of the potato. While the surface of the potato will heat up instantaneously, the center will take some time to equilibrate, and therefore, there will be a lag in the graph. But most importantly, we need to take into account our heat transfer rate. In heat and mass transfer, this is represented by a Q and is equal to the flux times the area that our heat is transferring through. But perhaps the most important governing equation for our experiment our heat transfer rate is equal to our overall heat transfer coefficient times the area our heat is transferring through times the change in temperature. This is what we want to increase for our experiment, the rate of heat transfer. So, in the case of the aluminum foil wrapped potato, we are changing the entire system. We are increasing our U and therefore causing an increase in our Q. So, we can redraw these graphs. On the x-axis we have time, and on the y-axis we have temperature. You can see that these plots are not linear. And that the aluminum foil does have a higher heat transfer rate. I provided a key here so you can see the difference between the surface and the center of the potato. While the surface does heat up instantaneously and the center takes some lag time, you can see that these two values do equilibrate by the time the potato is fully cooked. This should be an accurate representation of the plots for our girls and hopefully will predict our heat transfer rate for the experiment.
On your marks, get set.
Hold up. It'll be way faster if we peel it and cut. Because my graph, it's gonna look like that.
It's gonna take so long to prepare. Are you crazy?
Yeah.
We'll just have to see.
So for our peeled and diced potatoes, we can take a look at our overall heat equation. This is assuming one-dimensional transfer and constant potato properties like thermal conductivity. You can see here that the generation term goes to 0 because there is no heat generation coming from our potato. But our accumulation term, taking into account our thermal diffusivity, which is alpha, we can see that energy does in fact accumulate in the potato as it's heated up. So this equation can be reduced to, as we increase K by peeling the potato and changing its properties, this will cause an increase in your alpha and therefore an increase in the rate that your temperature is changing. But we can relate this all back and we see the same thing happening. Changes in our system by increasing the K will increase our U. The area changes by cutting up the potato are minimal, but The diced and peeled potatoes should heat up faster than our previously aluminum foil wrapped potatoes, causing an increase in Q that is the largest we've seen so far. So, let's draw our graphs again. We see our aluminum foil wrapped potato and our plain potato as we did before, but now there will be much less of a lag between the surface and the center due to the potato pieces being smaller. However, the diced potatoes will have the fastest rate of heat transfer. All right, let's see these girls in action. Let's get cooking.
These look so good.
The chopped ones smell really good. All right, let's all get a taste of these.
Now let's take a look at the scores. You can see that for our plain potato, the heat transfer rate wasn't the best, but this was the quickest and simplest method. So it got a pretty good score for speed. However, the taste, it wasn't the best. So that adds up to a score of 7. We can see that for our foil, the heat transfer rate was a little bit better, but it took slightly more time. However, the softer steamed skin appealed to some people's taste buds more. So, got a pretty good score of 9. However, the peeled and diced potato had the best heat transfer rate, but it did require a lot of preparation. It was seasoned, it was bite-sized, higher score for taste as well, making this the winner. I hope we all learned a little something about heat transfer rate today.
Guys, the line at McDonald's is so short. It only took 2 minutes, and these fries are so good.
Oh, I think this is 10 for speed, 5 for taste. This is the true winner!